Hey there, viewers. Thanks for tuning in to the Daily Space Weather. And what we're looking at here is imagery from three different sources. The SOHO-LASCO C2, the SOHO-LASCO C3, which is this blue circle. The red circle is the SOHO-LASCO C2, and the SDO is providing that helium imagery there. And we raised our coronal mass ejection warning from a coronal mass ejection watch yesterday. SMASH team would have heard all about it. Let's take a look at some more imagery here. Here's a close-up of just ionized helium from the Solar Dynamics Observatory. Coronal mass ejection warning continues. We've got massive filaments in the southeast. You can see down here two huge filaments. And we'll show more information on that later in the video. Here's your colorized magnetogram. We've only got two named sunspot groups. They've been mostly stable over the past 24 hours. Possibly some additional activity kicking up over here. We'll do a further analysis of that toward the end of the video. Here's a composite view, and we've got some missing data once again, which is creating like an optical weird effect here because one of those wavelengths lacking some data there. Same thing going on in the southern hemisphere. This is 171 plus 193 angstroms. There's a full disk view of that. It's not an optical illusion, folks. It's missing data from one of the wavelengths. The radio flux still quite low here. Low solar activity in general. And the radio flux is only at, I think, still 82 solar flux units. This is the one-year chart, the black line here. Oh, it's actually dropped down to 79. So 79 is the current 10.7 centimeter radio flux. And as you can see from this graph, the red line below the black line here, that's the sunspot number. And you can see how proportional the radio flux is to the sunspot number. There is some geomagnetic unrest forecasted for late tonight Universal Time and early tomorrow from another coronal hole wind stream from those South Pole-oriented coronal holes. We'll get to those in a moment. And let's take a look at global seismicity. There's a 7 magnitude earthquake drought continuing here, folks. That's the 90-day bar graph, and those red bars are 7+ magnitude earthquakes. Let's see what's been shaken over the past 24. There was a 5.1 in Turkey. So no major quakes here over the past 24 hours, but let me just remind all of our viewers that when we see a 7 magnitude earthquake drought, those end in large earthquakes. So if you're in an earthquake-prone zone, know which building facades might collapse if you're going to evacuate yours, etc. One of the largest quakes, I think that might be the largest quake of the past 24, was a 5.6 at Vanuatu. That one was over 130 kilometers estimated depth. And about a half an hour later, we saw a 5.1 at the Philippines, followed by only 5 minutes later, a 5.4 at the Philippines. So any of these could be foreshocks, folks. Remember, foreshocks can give us some advanced warning of an earthquake. There was a 4.6 off the coast of Oregon as well. So I know there's certainly been some flooding in the Pacific Northwest as well. And there's a pretty large quake also happening there, a 5.5 at Vanuatu, that one nearly 130 kilometers depth, that one coming in while we did our show prep. Next, looking at volcanoes. Here on Volcano Discovery's Volcanoes Today page. La Palma continuing to explode. A little increase in the size of the ash plume there. The ash plume now 10,000 feet as opposed to only 8,000 feet. Karimsky also erupting there in an explosive fashion on the Kamchatka Peninsula. 18,000-foot ash plume from Karimsky. Mount Ibu, 8,000-foot ash plume over Halmahera, Indonesia. As Mount Ibu explodes, Samisa Pochnoi could be erupting. No information provided there. Don't assume it's not erupting, although you're probably not there. The Aleutian Islands are a little bit desolate. Popocatépetl also exploding, 25,000-foot ash plume over central Mexico from Popocatépetl. One of my bucket list volcanoes. Fuego also exploding, 15,000-foot ash plume over Guatemala from Fuego. Nevado del Ruiz exploding, flight level 190. As Nevado del Ruiz explodes in Colombia, it's producing a 19,000-foot plume of volcanic ash. Revenador also exploding, 15,000-foot ash plume from Revenador. Sabancaya That one's located in Peru. 24,000-foot ash plume from Sabancaya as it explodes. Nevados de Chilean exploding. That's located in central Chile. It's producing a flight level 140 alert. It's a 14,000-foot plume of volcanic ash. Please don't fly your volcanic aircraft. Don't fly your John Denver-style aircraft through the volcanic ash plume. It could be unhealthful. Do visit our links. If you check out the Redbubble link below this video and you enter the promo code 25OFF apparel, you get 25% off all apparel for the next 3 days. Today's featured product is the Orange Classic Tea. My vaccination status is none of your business. HIPAA, the Health Insurance Portability and Accountability Act of 1996, has not expired, even in the pathetic year of 2021. So welcome to the Neo-Renaissance. You can find links to that merch shop right on our homepage there. Click the smAsho merch link and once again enter the promo code 25OFF apparel to save 25% on all clothing from the entire Redbubble site. Again, link to that from smashomash.com right on our homepage there to the smAsho merch link. You can also find a link to the Smash team there. More on that later in the video. Smash team knew about a coronal mass ejection warning yesterday afternoon. Let's delve into the realm of magnetic data. Here are the GOES magnetometers over the past 3 days. You can see they just diverged here while we did show prep. Yeah, so that's showing us a little bit of a variation in Earth's magnetic field. These are both geosynchronous satellites that are located near to the Earth's equator in their geosynchronous orbits. And if you're a new viewer, these M's and N's give us some indication as to the location of those spacecraft. Those stand for midnight and noon time for the satellites. So just coming off of midnight there for the GOES 17. Next, looking at the heliospheric current sheet, Earth remains in a South Pole current sheet shown here in red. No changes expected to come in that anytime soon. We've got 2 weak sunspot groups. We'll get to that in a moment. First, the line of sight coronal hole plot. And here's the line of sight ecliptic plane field plot. Nothing to write home about there. No major changes coming anytime soon. Here's a visualization of your coronal hole systems. And you can see another one rotating in here that is, again, South Pole oriented. As you can see there on the line of sight coronal hole plot. The blue lines there are the sun's B field, potential field surface source lines. And if you want to look at this yourself, it's part of the National Sunspot Observatory. Just look up the PFSS model data. Some very useful data there on solar forecasting. Trust me, I've become the world leader in this. So tell your friends and foes about the channel and help us out. For some reason, the algorithms don't seem to be helpful. Next, looking at flare probability, it's not very high at all. We've only got 2 sunspot groups. Likelihood of major flares is actually kind of low here. 2896 and 2897 are both alpha class sunspots with simple single polarity fields, not likely to produce major flares. There's only been 1 B class flare over the past 3 days, as you can see here from the GOES X-ray flux chart. That's the GOES 16 and GOES 17's X-ray detectors. Here is the proton flux, no spikes in that. Those coronal mass ejections we talked about were not Earth-directed. Let's take a look at the real-time solar wind next. We've just recently seen a bit of a change in the solar wind regime, and we'll be keeping an eye on this. We're expecting another increase in the solar wind density here. So a little bit of a gyration happening there. Not enough data to really produce a signal. Current conditions are about 9.3 protons per cubic centimeter. That's the solar wind density. Solar wind velocity, 526 kilometers per second. Global geomagnetism is at a KP index of 2. KP2 is the current geomagnetic calm condition. Let's take a look at the geospace. Out to about 12 radii as modeled by the Space Weather Modeling Framework. And this model is showing likely nanopascals. That's magnetohydrodynamic pressure. And we just saw a reduction happening there with this little gyration in the solar wind regime. Again, we are expecting a solar wind density increase to signal the beginning of the next coronal hole wind stream that's forecasted by NASA and NOAA late in the day, early tomorrow. Next, ground magnetic perturbations. There is a geomagnetic excursion going on. Perhaps there's always one going on, but in any case, here is the last 4 hours of data courtesy University of Michigan. Changes on the ground level. Geospace delta B changes to Earth's B field. Here's a diagram of the solar system. We're going to give you a 1-week forecast here. This is, by the way, theplanetstoday.com. And there's where things will be in a week. That was Mercury, by the way, that we showed earlier on the LASCO C3. Next, a star chart. And did you see our time-lapse video yesterday of the lunar eclipse? We got a great video of that. It's sped up 60 times, taking 1 image per minute. Anyway, that's where stuff is over my head. And my star chart faces the south. We're located in Lehigh Valley, Pennsylvania. And let's take a look at some coronagraphs once again here. Stereo A and the LASCO C3. They're located at Lagrange point 5 and Lagrange point 1 respectively. And they're on your left and right respectively. This is Stereo A and this is the LASCO C3. So this is the coronal mass ejection that we watched and warned about yesterday. There is still a coronal mass ejection warning in place at the moment. And we're mainly keeping an eye on, and when I say eye on, pardon the pun, we're mainly keeping an eye on the southeastern limb. There are massive filaments down there. We'll show you those toward the end of the video. If you haven't checked out our cosmology segments, please do. There's a playlist for it. Today's cosmology segment was a separate video. It'll premiere after the daily space weather, so make sure you check that out. Also, don't forget to check out the playlist, youtube.com/smashamash/playlists. There's all kinds of stuff you may not be seeing if you're only tuning into our daily space weather videos. Let's check out the likelihood of charging hazards on satellites. There is some likelihood here. Minor surface charging here located over the Central Pacific. And here's the electron flux over the past year. Relativistic electrons are encircling you here on planet Earth. Here's a measurement of them. That's from solon.info. Here's the last 3 days of measurements by the GOES 16 and 17. And you can see a similar divergence to the one we showed in the GOES magnetometers there. No surprise there, as electrons respond quite readily to magnetic fields. They weigh only about 1/1800th of the mass of a proton. Or I should say they weigh the weight of a, they weigh 1/1800th the weight of a proton. Don't get weight and mass confused, folks. Anyway, here's the relativistic electron forecast. We are expecting an uptick here. Well, NOAA's expecting an uptick. I think this is going to be relatively flat. We're going to see levels more like this, not levels like this. In my opinion, it's because of the coronal hole wind stream that's about to arrive. Here's a diagram of Earth's Van Allen belts because we're going to show you the total electron content, which is about that area there, the electron content of the inner Van Allen belt. Now, the closer to red you see here, the more likely you are to have a GPS error in that area. That's why we show it daily. But this also gives insight into Earth's geospace, Earth's own magnetic fields, and so on, as does the ionosphere. So we're going to show that next. The F ionosphere located at about 300 kilometers of altitude. Here's the vibrational frequency ionogram, courtesy Australian Government Bureau Meteorology. We've got some high-frequency anomalies here around the South American continent. Also some wild swings in vibrational frequency that I'm showing. And so, since it's easier to show you than explain, let's look at the anomalygram as well. There's the anomalygram, and you can see low-frequency anomalies happening there in red around the South American continent. Major low-frequency anomalies there. By the way, this is anomaly in megahertz from the 30-day median. Low-frequency anomalies all around the planet, really. And a bit of a lack of high-frequency anomalies. Anyway, here's the latest image. That's 11:30 Universal Time. And there's the anomalygram. Ionogram, anomalygram. And it's time to break out the bonus features. Starting with ground-based solar observatory hydrogen alpha imagery here from El Teide, Spain. And you can see these massive filaments down here. Those are the source of our coronal mass ejection warning. How we do it? Well, we haven't written the paper yet, therefore we're not telling you. Next, the latest colorized magnetogram and solar intensitygram to show you weak solar activity. So we've got this sunspot 2896, alpha class, unlikely to produce major flares. 2897, alpha class, unlikely to produce major flares. There's the colorized magnetogram to show you no other major activity kicking. Next, the GO16 SUVI imagery. And again, check out our Twitch stream. We actually captured the coronal mass ejection from last night on our most recent Twitch stream. Twitch.tv/smAsho will be streaming live again once again today, since the coronal mass ejection warning continues. Next, some composite imagery to close out the video. This is 131 and 304 angstroms together, so it's ionized iron and ionized helium from the Solar Dynamics Observatory. And again, this is the part of the sun to keep an eye on, and when I say ion, well, pardon the pun. We're doing what nobody else can, and nobody else will. Congratulations on realizing the channel exists, and may that solar wind be at your back.